Hey yo, what's good? Here we go again. I lied to you. I said we were gonna be quick scoping, but I was kind of hard scoping the first one just to get you guys going. So now I'm gonna rapidly go through the rest of them. Here we go. So this one is easy. You just factor out. You see n in the exponent. This, as n gets large, will be less than 1. In fact, when it's 2.001, it's less than 1 to the power of something. It will definitely go to 0. It will be bounded because it won't go to infinity before, and it will be decreasing to 0. Here, 11. N cosine n pi over 2. So basically, for each n equals 1, will be pi over 2. Which is 0, then it's going to be -1, 0, 1, 0. You get the drill, and constantly increasing by this. So what this is going to do is it's going to oscillate around 0, but the value of the cosine function will go to plus and minus infinity, but it's going to oscillate around 0. So that one was easy. That was easy. So number 15, we've got n squared minus 4 over n plus 5, and this shit easy. So what we're gonna do, we just divide by n and it will be apparent. Boom, son! So we got n minus 4 over n, this shit will go to 0, divided by 1 plus 5 over n. So basically it's gonna be n over 1, it's gonna be n, and as n goes to infinity, yeah, it's apparent, man. Easy. Quick scope, motherfucker. So it diverges to infinity. So number 17, if you look at this one, we do the same thing as up here. You just divide by n on both in the numerator and the denominator. So what you're going to be getting is 1 over n squared plus 1 over n. And obviously, this shit will disappear, this shit will be large, 1 over large becomes little, 0 in fact, and this stuff is just going to mean that it oscillates around 0, and it's going to go down like damping shit. You mean, when you're in your car like thugging around with the suspension, that's like a damping function. Just so you know, when you're cool out in the streets pimping shit. So now we're at number 19, and if you look at it, it will be apparent that this one is the same as 1 over e. This one will disappear, this one will also disappear because it's to the power of negative. These will be insignificant, it will just be this over this. So this shit's gonna go to number 1. And if you look at this one, you can this one is kind of interesting. As a matter of fact, we have n minus 3 over n, all this to the power of n. So what I do is the same thing as before. I divided the numerator and the denominator by n, where you get 1 minus 3 over n over 1. You can simplify it as 1 to the power of n, of course, 1 plus minus 3 over n to the power of n. And if the definition of e is 1 plus 1 over n to the n, this is e, and 1 plus x over n to the power of n is e to the x. Easy, man. So basically, this shit, as it goes to infinity, it's going to become e to the power of minus 3. Easy. And number 23, we have 2 square root signs. Each of them is a term in this expression. This will always be greater than this, but as n goes to infinity, they'll be practically the same size. The one here will become insignificant, so it goes to 0. Easy, quick scope. I mean, get on my level, bro. And for number 27, what we got is n factorial squared divided by 2n factorial. Alright, this seems really intimidating, but not if you're a boss. And what bosses do is they solve shit. So here's how we're gonna solve this shit. We're gonna put the shit in the sink. We're gonna put some acetone on there, and then we're gonna like squish it down the sewer. So here's how we're gonna do it. So we break this down. It's n factorial times n factorial, and this one will be 1 times 2 times 3 times 4 up all the way up to 2n. You get my drift. So if we write it, so what this means is basically 1 times 2 times 3 times 4 times blah 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 n times the same divided by all this. It will be 1 times 3 times 4 times n plus 1. So basically this is already n squared plus n, and this times n plus 2 is going to be like n cubed plus 3n. It's going to be a lot, and all the way up to 2n. I mean, and considering that n goes to infinity, we're going to have a huge number of terms, and we're going to have a huge number of numbers that are going to be multiplied by a huge number of numbers, a huge number of time. So basically, if you can grasp how fucking huge this is going to be compared to this, I mean, the biggest, if we group them together, the biggest term we're gonna get is like, no, that's a bad way to put it, but it's obvious that this one becomes way bigger, so it goes to 0, just like your swag.